When you have a partial fraction, the first thing to do is to examine the highest coefficient of both the denominator and the numerator. Now, here, the highest power in the denominator is 2, while for the numerator is also 2. That means both of them are equal. It's an improper fraction. Now, there are some cases where you have the power of the numerator to be far higher than the denominator. It's also an improper fraction. So the first thing we'll do, the first step here, step 1 is to divide. We're going to divide the numerator by the denominator. So that let's divide the numerator by the denominator. Now here's the numerator is 4x squared plus 9x minus 73, while the numerator is 4x squared plus 9x minus 73, while the denominator is x squared plus x minus 20. In dividing polynomials, our first consideration will be the highest powers. Now, so that x squared in 4x squared, I'll be left with 4. Now, 4 times 4x squared, 4 times x squared, I'll have 4x squared. The same 4 times x, I'll have plus 4x. And the same 4 times negative 20, I'll have negative 80. Now, you can now subtract this from what you have on top. We have a comprehensive lesson on how to treat denominators. We have a comprehensive lesson on how to treat polynomials. In case you missed that lesson, please do not hesitate to look in the description below. We'll place a link to that lesson. In subtracting, we'll now subtract 4x squared. We'll multiply this line by negative. So when I do that, 4x squared becomes negative, 4x becomes negative, and 80 becomes positive. So that 4x squared minus 4x squared, that's 0. 9x minus 4x, that's 5x. 73 plus 80 minus 73 plus 80, I'll be left with 7. That's plus 7. At the end of the day, I've been able to resolve this partial fraction to look like this: 4 plus 5x plus 7 over x squared plus x minus 20. Now the next thing is, the next step, step 2. In the next step, step 2, is to now decompose our 5x plus 7 over x squared plus x minus 20. If you observe that our x squared plus x minus 20 is a quadratic equation, so we have to break that down into linear equation. To factorize, my x squared plus x minus 20 becomes, now I have negative 20. In case you missed our lesson also on factorization of quadratic functions, I'll place a link in the description to help you access this lesson. Now this is x squared minus 20, that's minus 20x squared. Now to factorize this properly, we'll be looking for factors of 20x squared that when you multiply them, you come up with 20x squared, and when you add them together, you come up with x. For clarity's sake, such factor will be x, 5x, and minus 4x. So that this, my x squared plus x minus 20, can be written as x squared plus 5x minus 4x minus 20. So this is equals to x now comes out. X in x squared plus 5x, I'm bringing out x. I'll be left with x plus 5 minus 4. I'll be left still x. Minus 4 comes out. I have x in. Minus 4 in minus 20. I'll be left with plus 20. Now, when I have negative 4, the negative sign cancels the negative sign here to become a plus sign. Now, if you look at it the other way around, minus 4 times 4x, that's minus 4x, and negative 4 times 20, that's negative. This is 5. 4 in 20, that's 5. Negative 4 times 5, that's negative 20. So that I have this becomes x plus 5 into x minus 4. So I can, in place of x squared plus x minus 20 in this equation, I can now write that 5x plus 7 over x squared plus x minus 20 to be the same thing as 5x plus 7 over x plus 5 into x minus 4. Now, I have 5x plus 7 into x plus 5 into x minus 4. Now, from our former lessons on partial fractions, to decompose this is now easier. We can now do this as a over x plus 5 to be the same plus b over x minus 4. Now, we'll look for an LCM, and the LCM in this case will be x plus 5 into x minus 4. So I have x plus 5 in here. I'll be left with x minus 4. That's a into x minus 4 plus b into x minus 4 in here. I'll be left with x plus 5. X plus 5. Now this is equals to 5x plus 7 over x plus 5 into x minus 4. Obviously, our denominators are the same. I can either cancel out this or you just equate numerators. Now, so that I have 5x plus 7 to be the same thing as a into x minus 4 plus b into x plus 5. Now, let's expand the brackets so that I have 5x plus 7 to be the same thing as ax minus 4a plus bx plus 5b. So that now let's collect like terms. My 5x is plus 7 is equals to, collecting like terms, a plus b into what? Into x minus 4a plus 5b. Now the next thing is for us to now we'll equate coefficients. Let's equate coefficients so that where I have x, we'll equate them together. My 5 is equals to a plus b. Let's call that equation 1. And my 7, positive 7, will be the same thing as minus 4a plus 5b. Let's call that equation 2. Now the next thing I want to do is to solve this simultaneous equation. The easiest way I'm seeing to solve this simultaneous equation is to multiply equation 1 by 4. You multiply equation 1 by 4 and you add it to equation 2. Let's do that. So that 4 times 5, here I'll have 20. 4 times 4 times a, I have 4a. And 4 times b, I have plus 4b. Now we can now add both equations together. Minus 4 and 4a gives way. 7 plus 20, that's 27, is the same thing as 5 plus 4b, that's 9b. Now, if 9b is equal to 27, obviously my b is the same thing as 27 over 9, which is the same thing as 3. And for my a, 5 plus 5 is equals to a plus b. That means 5 is the same thing as a plus 3. In place of b, we can now substitute it for what? For 3. So that 5 minus 3 is equals to a. A is equals to 2. Now, if a is equals to 2 and b is equals to 3, we can rewrite our equation to be 4. Remember our equation, 4 plus 5x plus 7 over x squared plus x minus 20. So we can write our equation to be 4. In place of 5x plus 7, here can begin to substitute for a and b. Plus a is 2 over x plus 5 plus b is 3 over x minus 4. minus 4. Now with this, we've come to the end of this question, and I hope you understand how to solve partial fractions with improper fraction. In case you have questions, please don't hesitate to use our comment section, and we'll be there to respond to you. Thank you for staying with us, and do see you in our next lesson. Thank you.